Let's get right into it. Number 10, the 10% brain. Somewhere, there's a movie poster promising that if you unlock the other 90% of your brain, you'd learn 6 languages by lunch and move furniture with your mind. It's a beautiful idea. It's also complete nonsense, and your own skull is the evidence. Your brain is about 2% of your body weight, and it eats roughly 20% of your energy. 20%, that's a hungry organ. Evolution is famously cheap. It does not build a 3-pound luxury appliance, feed it a fifth of your calories every single day for your entire life, and then leave 90% of it switched off like an unused guest room. Biology doesn't pay rent on empty space. And we can look, brain imaging shows activity spread across essentially the whole thing over the course of a normal day. Not every region is equally active at the same moment. Widespread abnormal synchrony is closer to a seizure than a superpower. But there is no dark, dusty, unused continent in there waiting for a hero. Different jobs light up different neighborhoods, and every neighborhood has a job. The cruelest proof comes from damage. If 90% of your brain were dead weight, most strokes would be a minor inconvenience. Instead, a clot in a region the size of a grape can take away your ability to name a chair, recognize your own mother, or feel the left side of the world exists. That's not what a spare part looks like. Nobody's entirely sure where the myth started. It gets blamed on a misread line from psychologist William James, who said we use only a small fraction of our mental potential, which is a comment about ambition, not anatomy. Somewhere along the way, you could try harder, mutated into 90% of your head is a storage closet. So no, there is no locked wing of your mind. You're already running the whole machine. That's the disappointing part. This is you at full power. Number 9, blood is never blue. Look down at the inside of your wrist. There they are. Those calm blue-green rivers under your skin, the same color as the veins in every diagram your school biology textbook ever printed. Red for the fresh stuff, blue for the used stuff. Clean, tidy, and wrong. Normal human blood is never blue. Oxygen-rich blood is a bright, arrogant scarlet. Oxygen-poor blood is a deep, moody, dark red, the color of cherry cola in a dim bar. There is no navy setting. The blue appearance is an optical effect, not a biological one. Different wavelengths of light travel through your skin, get absorbed by tissue and blood, and scatter back toward your eyes in different amounts. What reaches you isn't the actual color inside the vein. It's the result of light taking a complicated trip through several layers of human packaging. You're not seeing blue blood. You're seeing your skin perform an accidental special effect. If you've ever had blood drawn, you already watched the myth die and didn't notice. That vial fills with something dark and red, straight from a vein, still comfortably lacking oxygen. It does not sit there in glorious blue and then blush, on contact with air like a shy Victorian. Here's the twist though. Blue blood does exist, just not in you. Octopuses, squid, and horseshoe crabs run on hemocyanin, a copper-based oxygen carrier instead of our iron-based hemoglobin. Copper goes bluish when it grabs oxygen, which is why a horseshoe crab bleeds something that looks like spilled antifreeze. And cells called amoebocytes in that blue hemolymph are extraordinarily sensitive to bacterial endotoxins, which is why the medical industry has harvested horseshoe crab blood for decades. So the aristocrats were never the blue-blooded ones. It was the sea bugs. It was always the sea bugs. Number 8, the tongue map. Picture the diagram. A cartoon tongue chopped into color-coded districts, sweet at the tip, salty and sour along the sides, bitter squatting way in the back like a bouncer. Generations of children were taught to eat as if their mouth were a parking lot with assigned spaces. That map grew out of a century-old misinterpretation. It traces back to a German researcher named David Hennig, who in 1901 dripped different flavors around volunteers' tongues to find where each one was detected at the lowest concentration. His actual finding was modest and boring in the best way. Sensitivity varies slightly across the tongue. Slightly. He never claimed sweet was banned from the back or bitter was exiled from the front. Then in 1942, psychologist Edwin Boring reworked that data into a graph, and the graph was easy to misread as a set of hard borders. Curves became zones. Zones became a diagram. The diagram became a textbook. The textbook became something your teacher said with total confidence while you nodded along. In reality, taste buds capable of detecting every basic taste are scattered all over your tongue, plus the roof of your mouth and down into your throat. Put a drop of sugar water on the salty region and your brain will report sweet without hesitation because nobody told your taste buds about the map. There are mild differences in threshold from place to place, which is exactly what Hanig said before everyone got creative with his homework. And while we're here, the classic 4 flavors were never the full roster either. Umami, the savory hum in soy sauce, parmesan, and mushrooms, was described in Japan in the early 1900s and spent most of a century being ignored by Western science because it wasn't on the chart. Your tongue was never a map, it was a crowd, and every member votes on everything. Number 7, the sugar rush. Every birthday party has that one adult standing by the cake, watching a pack of screaming 7-year-olds orbit the furniture, saying the same 4 words. It's the sugar talking. It's a satisfying explanation. It's also a belief that controlled trials have repeatedly failed to support, and it keeps walking around like nothing happened. Researchers have run this experiment more times than anyone reasonably needed to. Give children sugar, give other children a sugar-free substitute, make sure nobody, not the kids, not the parents, not the person with the clipboard, knows who got what. Then measure behavior. A landmark trial published in a major medical journal in 1994 did exactly this over several weeks with children whose own parents insisted they were sugar sensitive. The result? No meaningful difference in behavior or learning. A review pooling dozens of similar studies found the same flat nothing. Here's the part that should make you slightly uncomfortable. In a related experiment, mothers were told their sons had just been given a big dose of sugar. Half of them were lied to. Those kids got a placebo. The mothers who believed sugar had been consumed rated their child as noticeably more hyperactive. They also hovered more and criticized more while watching. The sugar wasn't in the kid, it was in the parent's head. And think about when children actually eat the most sugar. Parties, holidays, Halloween, situations involving other children, loud noise, presents, freedom from bedtime, and a bouncy castle. You could hand out celery at that party and still end up with a child on top of a bookshelf. None of this makes sugar innocent. It's a genuine problem for teeth, weight, and metabolic health, and those risks are boring and real and slow. It just doesn't reliably produce the dramatic, immediate, hyperactive rush people blame on it. The chaos was never chemical. It was the context, and a very convenient scapegoat wearing frosting. Number 6, horned Viking helmets. Somewhere right now, a football fan is wearing plastic horns in freezing weather to honor a warrior culture that would have found the whole outfit baffling. Not one horned helmet has ever been dug out of a Viking Age warrior grave. Not one. Archaeologists have spent well over a century excavating Scandinavian burials, ship graves, and battle sites, and the total haul of reasonably complete Viking helmets sits at about 1. The Geirmundbu helmet, found in Norway, a rounded iron cap with a spectacle-like guard over the eyes. Practical, ugly, completely hornless. Consider it tactically for a second. You're in a shield wall, packed shoulder to shoulder with your neighbors, everyone swinging axes in a space the size of a crowded elevator. What you want is a smooth surface that lets an incoming blade skid off your skull. What you absolutely do not want is 2 convenient handles that catch every branch, snag your own rigging, and let an enemy steer your head like a shopping trolley. So where did the horns come from? Mostly one guy. In 1876, a costume designer named Carl Emil Doppler dressed the characters of Wagner's opera cycle in horned and winged headgear, and the image was so gloriously theatrical that it escaped the stage and never came back. Romantic-era painters were already flirting with the idea. Opera sealed it. There's a wrinkle that keeps the myth breathing. Horned helmets genuinely exist in Scandinavia. A famous pair was found in a Danish bog, and they date to the Bronze Age, roughly 1,000 years or more before the first Viking longship ever scared a monastery. They appear ceremonial, not combat gear. So the horns are real, just filed under the wrong millennium. Vikings raided half of Europe wearing sensible hats, and history gave the credit to a costume department. Number 5, goldfish memory. The 3-second goldfish is the most confident lie ever told about an animal. It's so well established that people use it as an insult about their own forgetfulness, which is bleak when you learn the fish in question can be trained better than most houseplants and several coworkers. Goldfish form memories lasting weeks and months. This isn't a hopeful aquarium owner claim, it's ordinary conditioning work. Fish can be taught to associate a sound or a light with feeding time, then left alone for weeks, and they still show up when the cue plays. Others have been trained to push a lever or swim through a specific colored gate for food. Some experiments found fish that learned to avoid a spot where they had been netted and stayed suspicious of it long after. Then researchers decided to escalate. A team in Israel built a little wheeled tank with cameras that tracked the fish's position and translated its swimming into steering. An actual fish-operated vehicle. The goldfish learned to drive it across a room toward a visual target. They got better with practice. Some of them handled being placed in an unfamiliar starting spot and still found the target. That's spatial navigation, error correction, and transfer of a learned skill into a brand new environment. In a creature you were told forgets its own name mid-sentence, which reframes the sadder part of the myth. It's fine, he doesn't remember, was the excuse that justified the little glass bowl, no filter, no plants, nothing to look at, on the theory that every lap was a fresh new world. It isn't. It's the same lap, and something in there is keeping track. The goldfish remembers, it just doesn't have the vocabulary to file a complaint. Number 4, whiskey warms you up. There's a whole genre of imagery built on this one. The rescue dog with the little barrel, the flask passed around a freezing campsite, the shot of something brown and serious after coming in from a blizzard. It feels warm, it tastes warm, and it is actively making you colder. Alcohol is a vasodilator. It relaxes the smooth muscle in your blood vessels and the ones closest to the surface, in your skin, your cheeks, your fingers. Open wide and flood with warm blood straight from your core. That rush of heat against your skin is real, immediate, and genuinely pleasant. It is also your body's furnace venting itself into the open air. Your skin gets warm because your core is losing what it needs. Normally, cold triggers the opposite move. Your body clamps down surface circulation to protect the vital organs in the middle, which is why your hands go numb and pale in winter, while your heart keeps ticking along at a comfortable temperature. Alcohol interferes with that defense. It weakens the exact response trying to keep you alive, then hands you a warm glow as a receipt. It gets worse. Alcohol can blunt shivering, your body's built-in heat generator, and it wrecks your judgment about how cold you actually are. That combination is one reason alcohol and hypothermia make such a dangerous pair. In severe hypothermia, some victims experience a phenomenon called paradoxical undressing. Confusion and failing temperature regulation can make them feel unbearably hot, even while their core temperature is dangerously low. They remove clothing at exactly the moment they need it most, because the body's emergency system has begun sending instructions written by a malfunctioning thermostat. And the St. Bernard's brandy barrel? Never a real rescue tool. That came from a painting. A young English artist added the little keg to a dramatic alpine scene in the 1820s because it made a nice detail, and the monks of the great St. Bernard Pass have been explaining it ever since. Warmth you can feel, heat you're losing. It's the coziest way to freeze. Number 3, only 5 senses. Close your eyes and touch your nose. You just did something impossible according to the list you were taught in primary school. You didn't see your hand. You didn't hear it, smell it, taste it, and you didn't feel your nose until the moment of contact. So, which of the famous 5 got your finger to the target? None. That was proprioception, a constant stream of position data from sensors buried in your muscles, tendons, and joints, telling your brain where every part of you is in space without ever consulting your eyes. The 5-sense list is roughly 2,300 years old and belongs to Aristotle, who was working with the tools available, namely, thinking hard about it. Modern neuroscience counts far more, and the disagreement is mostly about how you define a sense rather than whether these things exist. Your vestibular system, tucked in your inner ear, tracks balance and acceleration using fluid-filled loops and tiny crystals. It's the reason a lift dropping makes your stomach lurch and spinning makes the room keep moving after you stop. Thermoception reads temperature through dedicated receptors, which is why menthol registers as cold when nothing cold has happened. Nociception detects tissue damage and is genuinely separate from touch. And interoception is the whole hidden department reporting on your insides. Hunger, thirst, a full bladder, breathlessness, the specific dread of your own heart pounding. That last one matters more than it sounds. A growing body of research links interoception to emotion itself. That the feeling of fear or excitement is partly your brain reading your own body's status and writing a story about it. You are not a creature with 5 inputs. You're a walking sensor array running dozens of channels at once, and the 5 you were told about are just the ones with obvious holes in your head. Number 2, hair grows after death. This one has legs because it's specific, it's not vague, spooky nonsense. It comes with a mental image. The exhumed coffin, the stubble, the fingernails that kept going after everything else stopped. It's the kind of detail that feels too grim to be invented. It's still wrong, and the truth is somehow worse. Growing hair and nails requires cell division, and cell division requires glucose and oxygen delivered by a circulatory system that is, at this point, permanently out of business. Within minutes of death, the supply chain collapses. Nothing is being built. The construction crew went home. What actually happens is dehydration. The body loses moisture, and the skin retracts as it dries and shrinks. On the face, that pulls back from the base of each hair, exposing shaft that was always there but sitting below the surface. At the fingertips, the skin around the nail bed shrinks away, revealing more of the nail and sharpening the ridge at its base so the nail appears to have pushed forward. Nothing extended. The landscape around it receded, which means the corpse didn't grow a beard. It got thinner in exactly the way that makes a beard look longer. People who prepare bodies for viewing account for this drying and skin retraction as part of post-mortem care. But the myth survives partly because it turned up in fiction. A famous First World War novel describes a dead friend's nails growing in the ground like corkscrews, an image vivid enough to lodge in a century of readers' heads. There's a reason this one refuses to die, and it isn't just morbid curiosity. Hair and nails feel like the parts of us that are already half dead while we're alive. Like you cut them without pain, you throw them away. The idea that they carry on afterward is really a question about whether anything does. They don't. The body just dries out and tells a very convincing story about it. Number 1, the lemming suicide. For decades, the lemming has been shorthand for mindless self-destruction. Politicians accuse each other of it. Video games are built on it. And the entire concept was cemented by a film crew that staged the behavior when the animals did not perform it naturally. Start with the biology, because the real thing is strange enough. Lemmings are small Arctic rodents with famously explosive population cycles. Numbers can boom to extraordinary densities in a good year, then crash. When it gets crowded, they disperse, sometimes in large numbers, moving across the landscape looking for food and space. Lemmings can swim, and a migrating group hitting a river or fjord will attempt the crossing. Some drown. That's a bad estimate of a water body's width. It is not a mass suicide pact, and there's no biological mechanism for one. Evolution does not select for enthusiastically deleting yourself. Now the film. In 1958, Disney released a nature documentary that included the definitive footage, lemmings streaming across the tundra, gathering at a cliff, hurling themselves into the sea. It won an Academy Award. It taught the world a fact that did not exist. A Canadian investigation in the 1980s went back and found how it was made. The sequence was shot in Alberta, landlocked, with no lemming migrations and barely any lemmings. The crew bought a small number of animals brought in by Inuit children, put them on a snow-covered turntable to fake a stampeding herd, then herded them off a riverbank into the water. The narration explained the tragic instinct. The camera had produced it. So the most famous animal behavior in popular culture was staged, and millions of people learned a fake fact from a film that won an award for showing them nature. The lemmings never jumped. They were pushed and then blamed for it. That's all for today. I'll be making similar videos in the future. Subscribe to see them.